Hello everyone, this is the video lecture for College Algebra, Math 1414, Section P1. So I'm doing these lecture videos so that you can partake in the class, I guess you could say. I'm going to be doing not all of the homework problems, but I will be doing problems from the homework. So I'll be listing out what questions they are. I guess my style of doing this is something like P11111. This is the number that's in the book, but it's also what you can find in my math lab to find this exact same problem on your homework. Now, typically I also start with the first problem on the homework, so this very well may be number one on your homework. It's just it has an identifying code there. So again, though, I won't be doing all of the homework. I have to leave you to do some of it, of course. But I try to do some of the harder ones, some basic ones also to kind of get started on it, and I just pick and choose ones that I really like, meaning they're good and they're important. And so let's get started, and here we go. So P1 in particular, there's nothing really big to talk about here. P stands for preliminary, and so we're just going to go through the preliminaries that we're, I guess, in a way, assuming that you've seen before. So you might not have seen it, and that's okay. That's why we're going through it here. But a lot of these topics that I'll be covering here in this section in particular and the ones to follow are things that, again, are assumed. And I might not assume that so much with you, but let's just get started. You'll see what I'm saying. So I got x squared minus 8 times x minus y. You'll notice that I have terrible handwriting, but you'll get used to it really quickly. They also say that we got x is equal to 8 and y is equal to 1, and they just say plug them into the expression and figure out what the number is. And that's all you're doing. It's called substitution. Wherever you see an x, you're going to put an 8. So that's 8 squared minus 8 times x is, again, 8 minus y. What's y? 1. And so you just substitute those in, and then we're going to simplify. Order of operations, that kind of stuff here. I guess you've maybe heard of PEMDAS. Regardless, though, I'm just going to go through it here. 8 squared is 64. On the inside here, we got a 7. 8 times 7 is the 56. And when you subtract them, you get an 8. Cool. And that's it. Normally, what I do for my answers is I box them in. You'll be seeing that as we keep going. Well, there you go. And in class, I would stop and see if there's any questions. Because this is recorded, I guess I can't. But always, you can email me if you have questions. You could use the Ask My Instructor button on my Math Lab homework. And they will, it'll redirect it immediately to me in my email. And then we could talk about it. So again, that's Ask My Instructor button. Well, you get the idea. It's probably under like question help, and this is on every single one of the homework questions. So you click the question help button, you choose the Ask My Instructor, and it'll email me directly with what you're looking at, what you've done. You could even talk about stuff. You could chat, and then I'll get it on my email, and I'll reply back to your email as well. Okay, so that's pretty cool. I think it's a good tool, and it's very reliable. Okay, so the next question, I just started writing it here. They got h is equal to this big old formula thing here. That's a plus sign, and those are t's. You can see the little tail on them. And they're saying, blah, 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 word problem, t equals 3 seconds. Now, I'm not going to write out all the words of a word problem. I can't remember what this word problem is. I just have my copied notes here. But the point is that we're trying to deduce that it's not just this big word, I don't know what's going on. A lot of words are intimidating. Instead, it's just math here. All we're doing here is just some numbers. They say t equals 3. You're going to put a 3 in right there, and that's it. I mean, that's it. You're not doing much else here. So you put a 3 in there. You're substituting t equals 3. There you go. I would say start with this guy first, not the 16, but the 3 squared makes a 9. You could also do this right here, 3 times the 55. I can't really remember what that is right now. But the point is that you're trying to do order of operations, and powers will come first, and then you got that multiply kind of thing. Again, this is preliminary stuff. I'm assuming you already know it, but I'm not really assuming you're knowing it. That's a lot of numbers. Honestly, I'm just going to put this all in a calculator at once. And I got 26. That's what I did on my paper, at least. Now, when I say calculator, you could use the Scientifics. There's some TI stuff. We got Desmos.com. There's a lot of places that you can go to get a scientific calculator. By scientific, I'm just meaning it has a lot of fancy functions, and you could do numbers as well, okay? Later in the class, we'll be talking about graphing calculators, but not right now. We got a way, way long time to go. P155. Again, this could be number 3 on your homework. It could be number 7. I can't really remember, but that's not the point. Look for that identifier, or you'll just see this problem and know exactly what's going on. So I've got the absolute value. Those are those big bars on the side here. Absolute value of the square root of 6 minus 7. It says equals what? Go, figure it out. My first inclination is to just go and put this all into a calculator. So I'm going to start with just doing the inside, okay? Maybe I don't know where the absolute value button is on my calculator or something like that. I don't really know. So I put square root 6. Again, on older calculators, it might look like this here. On the newer calculators, you could do this. But make sure that it doesn't extend. You don't want that. You want to like basically stop it early. On a lot of programs, if you're using the computer, you would put the 6, and then you kind of like arrow out. You arrow to the right to get out of there, and then minus the 7, and etc. Just make it look like it looks. You know what I mean? And so I put this in the calculator, and I got a negative 4.55051 ... It keeps going forever and ever. That's not what they're looking for at all. Because, for one thing, is the absolute value of this. The absolute value. Maybe I'll write that up here. I say it really fast. Sorry. Absolute value. What does the absolute value mean is that it's going to be always positive. Always positive. So, like, whatever we had here, I'm going to rewrite it now with the absolute value. I'm just going to say positive 4.55051. And so that's the answer, right? Boom. No. They're wanting exact answers. They say that in my math lab in the little blue here. They'll say something like, use exact answers, or something kind of like that in the blue. Kind of telling you that you need to do something more than just a calculator here. It might even say, don't use a calculator. I can't really remember. And so this is not good enough. I know that's the answer, but it's not what they're looking for in this particular case. So how am I supposed to do this problem? Well, I'm going from a negative on the inside to a positive. I'm definitely changing its sign. I'm changing its negative sign to a positive sign. There's a couple ways you could do this. Like, I'm just going to make up a point here. Like, here's an example on the side. Let's say that I had 2 minus 3. This is a lot easier problem. And so on the inside, we got a negative 1. And so then absolute value of negative 1 is a positive 1, right? Cool. So I'm saying we could take this inside, just like what we did, and they say, oh, well, negative 1. No, I want to make it positive 1. You just change a sign, S-I-G-N sign here. Cool. Well, notice that our original was 2 minus 3, right? The absolute value of that. And we got a negative 1 out of that thing. How would I get a positive 1 out of this? From these numbers, this expression, how do I get positive 1? What about 3 minus 2? Wouldn't that make a 1? A positive 1? Notice that what I did here, I'm going to use a different color here for a second. I basically, I swapped them, I guess you could say. I don't really like saying swapping them. I'm changing their signs. Technically here, I would say this is going to be a negative 2 plus the 3, and that should make a positive 1. I'm just changing their signs. This was a negative, or that was a positive, now it's going to be a negative. That was a negative, now it's going to be a positive. I'm changing their signs to change the sign. S-I-G-N sign. Blah, blah, blah. Back to original. Maybe I'm just doing too much theory here. I got this guy here. What if I just swap them? And that's your answer. That was it. The whole time. Blah, blah, blah math. Technically what I did is I said that negative 7 turned to a positive 7. That positive square root 6 turned to a negative square root 6. That's really what's going on here. I just wanted to show you the quick way as well. Okay, so that's a kind of a little bit confusing problem. There will be a couple of those in the class, and I intend on doing most of them for you, with you, not for you, with you. I'm doing them for you in front of you, but when you go there to your homework, you'll be doing it with me, I'm supposing. Different numbers, different randomizations, and all that stuff. Okay. And so the next one says, we got this expression, simplify. So simplify, we're going to first off distribute the 2 to make 10x minus 8 plus 11x. That's distribute. And then I'm going to combine like terms. These guys here, they both have an x. So I got 21x and then minus the 8, and that's it. Pretty simple here. So again, distribute, combine like terms. Those are just, again, preliminary things that we're assuming you've kind of seen before. Maybe you haven't done them in a couple years, I don't know. But that's why I'm still doing them and trying to explain it a little bit as well. I don't want to assume that everyone's 100% on this stuff. I mean, you are just starting to take the classes day one, right? So they got this other expression, simplify, etc. Notice that we got all kind of parentheses and minus signs, and oh my gosh, it kind of looks crazy. I'm going to say start from the inside and work outward. And so there's nothing really to do here. You can't combine them. You got a y and you got a regular number. Nothing to do there. The minus sign here, this is technically a -1 in the front. It's invisible 1. But minus sign, I'm going to distribute to both of these terms. And so now I got a negative 6y, and then 2 negatives will make a positive 5. Combine like terms wherever we can. The 8 and the 5 here, they're the same thing. And so that would make whoa, I guess I just skipped ahead on my paper here. Whatever I do on my paper, my notes, you can't see them, obviously. I guess I skip steps occasionally on myself, but I don't want to skip steps with you. So I combine those to make a 13 on the inside down. Notice that we got these square brace things, these brackets. It's the same thing as parentheses. They're just like really big parentheses. But it's just parentheses here. Not a big deal. I would say distribute again, because you got parentheses, right? You want to distribute. You can distribute the 7. You can distribute the minus sign. Or you can distribute both at the same time. I'm going to do both. I'm going to do both here just because I feel like it, I guess. I don't know. But you could definitely do the 7 and then the minus sign if it's too much all at once, you know what I mean? Up to you. I'm going to distribute the -7. So then I got a negative out of this. And 7 times 13 is a calculator moment. Come on, I don't know anything past the 12s, right? Do you? Right? Weren't we all taught to multiply up to 12s, and that was good enough? 7 times 6 is the 42. Good thing I got a calculator right here next to me. And that still has a y. Combine like terms, these guys right here. And so I'm going to write this to make it pretty by making the 42y in the front because it's positive. And then we're going to have a negative. And then we got a -91 plus the 6. That's a positive 6 right there. I got a -85. And yep, that's what I got on my paper. Cool. Again, I did something different on my paper. And so could you do something different to get the same answer? Sure, that's fine. One thing about this problem in particular is that it's using y's. And so I'm going to put a little note here because I put a note on mine. Make sure that you're going to use, so to use y. You want to use the y letter. So as you're typing this into my math lab, make sure you just type y, like on the keyboard, y, and you'll get y out of it. Don't use x. Normally we use a lot of x's in this class. We're trying to throw you off. Okay. P1119. This is a pretty big one here. I got 8 minus 9 squared minus 2 times, whoa, absolute value. So those vertical lines there. 7 minus the 12. Then all divided by 117 minus 2. And then they got a dot here, 6 squared. Now that dot means time sign, of course. This is a lot going on here, and we need to find out what that number is going to be. I would say, again, work from the inside out. And so some groups that I see that I can use first is right here. I could probably do this guy here. The square comes before the multiply. So you need to definitely square this first, and then you can multiply it by the 2. That's that PEMDAS stuff. Parentheses, exponent, and multiply. Yeah, there you go. That PEMDAS. Trying to spell it out in my head here. So I got a -1 squared minus 2 times absolute value of whatever this is -5, right? And then all divided by the 117 minus 2 times 36. Okay, let's, keep simplifying here. We got -1 squared, 2 negatives make a +1. And I'm going to do this thing first, this absolute value. And so what I have is a +5 out of that. You don't have to put the plus sign, but you get the idea. I'm just saying that this right here, this thing turned into a +5. I haven't multiplied it yet. I'll get to that here in a second. Hold on. Let me use my red there. There you go. Now you can see it a little bit better. And then, of course, on the bottom here, I still got the 117, and 2 times the 36 is going to be a 72, I believe. Yeah. Okay. Now I'm going to multiply, make it a 10. These guys down here is a calculator moment again. 117 minus 72 is a 45. There you go. On the top here, I'm going to subtract to make a -9. 45. Uh-oh, fractions. Dun, dun, dun. It's kind of interesting here. You could take each of these individually and divide them both by 9. I would say this is like old school method here. So then you would get a 5, I think, here? Yeah. There you go. That's old school method if you kind of know what's going on. If you don't, I would say at this point right here, you could jump to the answer if you use a calculator. And so scientific calculators, I don't know, Desmos, GeoGebra, your TIs, whatever. There's the TI-30s, there's the TI-83, 84s, there's the Casios, all kind of things here. Definitely have the ability to go from a crazy little fraction into a more simplified fraction. In particular, on the TI-83, 84, and all that kind of stuff, they got this math to frac button. So you press the math button, and then like the next button that you'll see is frac. So basically math, enter, and it just automatically changes this thing over to this thing, and everyone's happy with that. Of course, on the Casio, there's a whole lot of different Casios. They got the FD button, and so whatever your result is, just hit that button, and boom, there you go. You get a brand new cool answer. Lots of different ways to get this simplified stuff. Okay, so I'll probably be doing that as we continue on, because I'm guessing you have a calculator next to you. Okay, P1112. I don't know if your phone will do it. Well, I mean, your phone will do everything. It's just trying to find the right thing, I guess. Your typical calculator app might not do that, but maybe it does. I don't know. This one's a word problem here. It says, I'm going to use quotes here, a number decreased, I have to say it because you can't read it, by the difference between 8, of course they couldn't even write a number 8, and the number. I'm going to re-say it one more time here. A number decreased by the difference between 8 and the number. Okay. What? In math land, when I say a number, what's the first thing that comes to mind? X. Yep, very good. So I got X. Decreased means subtraction. I can just hear y'all saying these and repeating it to me right now. From beyond the time and space. By the difference between, whoa. Now, difference to me also means subtraction. But when you insert that between part, they're trying to say, like, this is its own little subset. So I'm going to have another thing here with a minus sign between it. And I got two different elements kind of here. 8, that's pretty simple, and the number. It's probably x. I wish they would have said that number. That would have been a little bit better, more clear. So I'm going to distribute the minus sign here. X minus the 8, two negatives make a positive. X. Combine like terms, this is a 1, this is a 1. So when you combine these together, you actually make 2x minus 8. And, well, you're done. That's it. That's the entire problem. Well, it wasn't too bad, I guess. Okay, P1131. This problem here is super intimidating, and it's also super important to you as we continue on through the rest of the class. If I could give you like a hand sign or a wave, or if I could wink at you, I would. I could whistle. There you go. So this is important. Pay attention to this guy here, please. And it has this picture on the side. It's a lot of words and stuff, but it has this picture on the side over here. 2010. And then we get some kind of dollar figure up here. We got a 26,551. Okay, cool. They say that X is years after 2000. Yep. Okay. And there's a ton of words here about what's going on. I think it's like tuition rates or something with colleges, or I don't really know. Something like that. They're wanting to find the average cost in 2010. And it's right there. But no, kind of kidding with you. They want to use this formula to find a more accurate number or something, whatever. So years, X is years after 2000. We're going from 2000 to 2010. And so how much X do we got? We got X equals 10. Yep, obviously. So I'm going to take that X equals 10 and plug it in here. 26 times the 10 squared plus 820 times the 10 plus 15,764. Yeah, there's a lot of calculator there. And I got 26,564, and that's in dollars. And that's actually your answer to part A in my math lab. Now, at this point, if you've been going through the homework with me, of course I've skipped some of them. But yeah, I mean, you could pull this right up, right alongside it and kind of work with me if you wanted to, I guess. My math lab homework works interestingly because they'll give you part A, and they won't show you anything else until you submit part A. So you submit part A, cool, and you think, man, I'm done. That was easy. Well, no, now we got a part B, and they give you a lot of other stuff to do. So watch out for that. That behavior does not occur on quizzes and exams. On quizzes and exams, they give you the whole thing, part A, B, and C, all is visible all at once, thankfully, so you know what you have to do. And we could talk about that as we keep going, or you can even ask me questions about it. So I got part A done. Cool. Part B says, now compare with the graph. And that's where that big old graph is coming into play here. We got this guy. So that's basically what I really found, and this is what I was expecting. And I want to know, is this overestimating the graph? Or is it underestimating? You get the idea. Over or under, and they got the two boxes. You're going to choose which one to put it in. Mine, if you notice the difference between these two here, mine is bigger by a little bit. So I'm definitely clicking the overestimate. I'm going to have this box here. That one's grayed out. You don't need that anymore. But how much am I overestimating by? And so how do I find that? I'm going to subtract them. It's a 551. And so doing the math in the calculator, $13. We don't do subtraction like this anymore. Nope, not anymore. We got calculators for that. But it's funny to see. Part C. Oh my goodness. Okay, so that's part B. Part C, it says, well, now use that formula that we had up above for the year 2019. What's going on there? Well, basically, x is equal to 19, and so I'm going to plug that into my formula, right, like this guy right here, the original. Just like I had done earlier in part A. So I'm just copying it down. 5, 7, 6, 4. Yep, okay, good. And you get an answer. And they say, calculator, of course. I would definitely recommend calculator. 40,730. And there you go. Cool. And then you're done with that problem. Okay, and actually, I'm done with that section. Isn't that cool? So I'm going to be splitting these videos up into different sections. That way, they're easier to kind of take in. I'm not going to like do the whole chapter all at once, kind of thing. So I guess that's it for now. Again, if you ever have any questions at all, you just let me know. You can email me directly. You can do a Blackboard message. That's very reliable. You can do the Ask My Instructor in my math lab. Lots of ways to get a hold of me. So that's it. Thank you very much, guys. Have a great day.